Problem 1 is a 10-question true-false test. N is 10. And in order to pass, we have to get at least 8 questions correct, so that x is greater than or equal to 8. The probability of guessing correct on any particular one question is 1/2, which is 0.5. We have the important pieces of information. N is 10, the value of P, and the question itself, at least 8. Probability of getting at least 8 guesses correct is P of 8 plus P of 9 plus P of 10, in which we must use the binomial formula, P of x being NCX, P to the x, 1 minus P to the n minus x. We're going to have to use this formula for the value of x being 8, 9, and 10, with n being 10 and p being 0.5, which represents the probability of a correct guess in a true-false testing scenario. P of 8, 10 C8, 0.5 to the 8th power, 0.5 to the 10 minus 8. Notice this comes from the complement of P. This is a probability of guessing correct. This is a probability of guessing incorrect. Notice that 1 minus 0.5 again is 0.5. This will equal 10C8, 0.5 to the 8th power, 0.5 to the 2nd power, which is 10C8, 0.5 to the 10th power. So if we go out to the tens, hundreds, 10,000ths position, the 9 is in the 10,000ths position, digit to the right is a 4, the answer is going to be 0.0439. This is the answer for P of 8. P of 9, 10C9, 0.5 to the 9th power, 0.5 to the 10 minus 9th power, 10C9, 0.5 to the 9th power, 0.5 to the 1st power, 10C9, 0.5 to the 10th power. Find our combination key. This is 10C9 times 0.5 to the 10th power. The 7 is in the 10,000ths position. The digit to the right is a 6, so the answer is 0.0098. This is approximating to the 10,000ths position. P of 10. 10C10. 0.5 to the 10th power. 0.5 to the 10 minus 10th power. 10C10. 0.5 to the 10th power. 0.5 to the 0 power. Now, 10C10 is the value 1. Any number to the 0 power is the value 1. So the answer is 0.5 to the 10th power. We're going to see what this is approximately. Scientific notation. It's 9.765625 times 10th to the minus 4 power. What that simply means is move my decimal 4 spaces to the left. That will give me about 3 zeros in front of the 9. So if I look at this answer, and I approximate to the 10,000ths position, the 9 is in the 10,000ths position, the digit to the right is a 7, so I add 1 to the 9, making it a 10. The answer will be 0010, approximately. So remember, at least 8, I'm going to take the 0.0439 plus 0.0097 plus 0.0010. The answer is approximately 0.0546 to answer the at least one question. Excuse me, at least 8. Now the answer on the sheet is approximated to the thousandths position. The digit to the right is a 6, so you add 1 to the 4 and you get a 5. The answer is approximately 0.55. Question 3. In question 3, they are to select 10 students. Again, n is the value 10. In this question, we let x be the number of ethnic minorities. I'm going to talk about no more than 6. So you're going to select 10, and they're going to ask you the question, what's the probability of selecting no more than 6 ethnic minorities? So x here is less than or equal to 6. I want to point out that 33% of the population are ethnic minorities. So the probability of selecting a one ethnic minority is 0.33. The complement, which is a non-ethnic minority, will be 1 minus 0.33, which will give you 0.67. To recap, n is 10, p is 0.33, 1 minus p is 0.67, and we have to deduce the probability that x is less than or equal to 6. In this question, the probability x less than or equal to 6 means x is 0, or x is 1, all the way up to x being 6. This is a good number of probabilities to compute using the binomial. I think I'm going to use the complement rule. It's 1 minus the probability of the outcomes that are not here. The outcomes that are not here are the values x is 7, 8, 9, and 10. I have to use the binomial for each one of these scenarios. N is 10. P is 0.33. 1 minus p is 0.67. X is 7, 8, and 9. P of 7. 10C7. 0.5 to this is where we're going to make a mistake. If being an ethnic minority here is a success, the probability of a success is 0.33. 0.67 is the complement, and we have 10 minus 7. This is going to be 10C7, 0.33 to the 7, 0.67 to the 10 minus 7 is 3. Math, probability, combination. 7 times 0.33 raised to the 7 times 0.67 raised to the third power. 0.01538. If we approximate to the nearest 10 thousandths, the 3 is in the 10 thousandths position. The 8 says add 1. So it's 0.0154. It's P of 7. P of 8. 10C8. 0.33 to the 8th power. 0.67 to the 10 minus 8th power. Becomes 10C8. 0.33 to the 8th power. 0.67 to the second power. We'll see what this is approximately to the nearest 10 thousandths. The answer is what we see here, and the 8 is in the 10,000ths position. The digit to the right is a 4, so we do not add 1 to the 8. The answer is 0.0028. P of 9. P of 9 is 10C9. 0.33 to the 9th power, 0.67 to the 10 minus 9th power. 10C9 will be 0.33 to the 9th power times 0.67 to the first power. Let's see what this value is approximately. Now 0.67 to the first power is just 0.67. We can enter and see that this is approximately, well, we get scientific notation here. We got to move our decimal 4 spaces, here's the 4, and it's negative to the left. So if we have 3.1, and we got to move this 1, 2, 3, 4 spaces, there are 3 zeros in front. The 3 is in the 10,000ths position. The digit to the right is a 1, so the answer is approximately 0.0003. P of 10. 10C10. 0.33 to the 10. 0.67 to the 10 minus 10. 10C10. 0.33 to the 10th power. 0.67 to the 0th power. Because 10 minus 10 is 0. 10C10 is 1. Any number to the 0 power is 1. So the answer is 0.33 to the 10th power. I want to see what this is approximately. Again, scientific notation. Now you have 1.53, and we have to move that decimal 5 spaces to the left. So that means we have 1, 2, 3, 4 zeros, 153. So if we approximate this answer to the nearest 10, 100,000, 10,000ths, you would get an answer that's approximately 0. Now, I'm going to actually keep an extra decimal place in this example, just to emphasize to you, or to remind you, because sometimes students get a little confused if you approximate 0 with being 0. So I'm going to keep that 1 just for now. But it is acceptable to say that that is approximately 0. So we're going to have to use our complement rule. If you recall, what we're trying to do is determine the probability of selecting no more than 6 ethnic minorities, and that's done by using our complement rule. 1 minus P of 7, minus P of 8, minus P of 9, minus P of 10. Let's see what this answer is approximately. In order to do this, I'm going to have to go back and scroll to find all these values starting with P of 7. I'm going to subtract 0.0154 from 1. I'm going to subtract 0.0028 I'm going to subtract 0.0003. Then I'm going to subtract P of 10, 0.12341. And we get 0.98149 as our answer. Now, if we give this answer to the nearest tenths, hundredths, thousandths, 10,000ths position, the digit to the right is a 9, which means add 1 to the 4. The answer is approximately 0.9815. That's the likelihood of selecting no more than 6 ethnic minorities. Question 5. Question 5 is a standard batch acceptance plan. They're going to select 26 components. N is 26. They're going to accept the batch if they find that fewer than 3 are defective. So, fewer than 3 are defective. Let X equal the number of defective components. So fewer than 3 means simply X is less than 3. What they're saying is that 3% of the batch is defective. In other words, the probability of a success, since we define defectiveness to be our success, the probability of selecting a defective component would be 0.03, corresponding to the fact that 3% of the batch is known to be defective. So we have N, we have P, we have the complement of P to be 0.97, and we have, ladies and gentlemen, the values of X. All the information needed to answer the question. We're going to use our binomial formula. The probability of accepting the batch is the same as the probability and finding that fewer than 3 components will be defective, all using the binomial formula. Now remember, probability that fewer than 3 is 0, 1, or 2, meaning no components are defective, 1 component is defective, or 2 components are defective. These outcomes describe fewer than 3. Now, remember, N is 26. We're selecting 26 components. P is 0.03. The complement of P is 0.97. Complement of 3% is 97%. X are the values 0, 1, and 2. Let's see what we get. P is 0. 26, C0. 0.03 to the 0. 0.97 to 26 minus 0. 26, 0. 0.03 to the 0. 0.97 to the 26 power. 26C0 is 1. Any number to the 0 is 1. So the answer is 0.97 to the 26 power. Let's see what this is approximately. .452965. Let's approximate this answer to the nearest 10 thousandths. So we see that 9 is in the 10 thousandths position. The digit to the right is a 6. So if we add 1 to the 9, that makes it 10. Or if we add 1 to the 29, we get 30. Either way, the answer is approximately 0.4530. This is P of 0. P of 1. 26, C1. 0.33 to the 1. Excuse me. This is not. It's no longer the question we are answering. That was back in 3. 0.03 to the first power. The complement, 0.97, 26 minus 1. 26C1, 0.03 to the first power, 0.97 to the 25th power. Let's see what we get. 26 C1 times 0.03 raised to the first power times 0.97 raised to the 25th power. So the 2 is in the 10 thousandths position, and the digit to the right is a 4. So the answer is approximately 0.3642. Finally, P of 2. 26C2. 0.03 to the second power. 0.97 to the 26 minus second power. 26C2. 0.03 to the second power. 0.97 to the 26 minus 2 is 24th power. .02 times 0.03 raised to the second power times 0.97 raised to the 26 minus 2 is 24th power. The 8 is in the 10 thousandths position. The digit to the right is a 1. So we do not add 1 to the 8. The answer is approximately 0.1408. Now remember, we're looking to accept this batch, and we only accept when there's fewer than 3 components that are defective. So the likelihood of accepting a 26 component batch becomes found when we sum each of these probabilities, where the outcome was 0, 1, and 2. So in order to do this, we have to scroll back and find each of those probability values. Point 4530 plus 0.3642 plus 0.1408. We find the answer is approximately 0.958. Question 7. Question 7 is an expected value question for a binomial. When you have a binomial, we can compute the expected value very easily. Mu is a product of NP. So in question 7, there's 16 items. 22% is what they're describing for P. So it's 16 times 0.22, as 22% in question 7 are students who work full-time. 22% is 0.22. So then mu is going to be the product of 16 times 0.22. We find the answer is 3.52. In question 7, the mean of students who work full-time when the sample size is 16 will be 3.52, and that's because 22% are students who work full-time. Finally, question 9. Question 9 is asking to find the standard deviation for a binomial. Standard deviation for a binomial, there's a shortcut. The formula is sigma is the square root of NP times the complement. In question 9, your batch of batteries is 11. So N is 11. A 3% rate of defect. So P is 0.03. Now the complement of P will be 0.97. So that the standard deviation is found by taking the square root of 11 times 0.03 times 0.97. We'll see what this is approximately. Close your parentheses. What we see here is the answer is approximately 0.565777. If we approximate this answer, say it's the nearest hundredths, the 7 to the right is going to say add 1 to the 5, making it a 6. So the answer is 0.566.